Reminder, here are the steps we use whenever we use a triangle to solve problems. And this video is going to focus on using triangles to help us solve using the half angle identities. So here are your half angle identities. This is for sine of theta over 2, cosine theta over 2, and there are 3 choices for what you can use if you want to find tangent theta over 2. They rationalized this denominator and then replaced some things with Pythagorean identity to get these 2 versions. I personally prefer that one because I don't like square roots and I like my denominator to be as simple as possible. But all 3 of these will work for all of these problems. Let's do an example. Okay, they tell us that cosine is negative 5/3. This is the fraction, negative 5/13. And then they tell us this really weird way to say we're in the second quadrant. When you write out your coordinate plane, you go from 0 to pi over 2 to pi, 3 pi over 2, and 2 pi. So if theta is between pi over 2 and pi, that means we're in the second quadrant. That's what that means. You need to look at your axes and figure out between these which 2 numbers tells me which quadrant I'm in. So draw your triangle in the second quadrant against the x-axis. The adjacent side is always the x-axis, the opposite is always the vertical line, and the hypotenuse is the slanted one. And I'm going to go on and fill in the signs. So this is the negative x direction from the origin. This is the positive y direction from the origin. And then the hypotenuse is always positive. Okay, let's label my triangle with numbers now. So the adjacent side is 5, because that's the and the hypotenuse is 13. You don't really use this negative here as long as you labeled your triangle with orientation, but you can see it confirms that negative 5, positive 13 is a negative fraction. So that's where that negative comes from. It doesn't necessarily have to go with the 5 though, depending on which fraction they give us and how our triangle is oriented. Anyhow, all right, we have our triangle set up. Let's find this third side using Pythagorean theorem. Oh, that is really crooked. Anyhow, okay, we got our whole triangle set up. Now we're ready to do sine theta over 2. When we do these problems, it's a lot of algebra. So you have to be really good with your, can I find a common denominator? Can I keep, change, flip? All of that. Make sure you keep everything straight and make sure you don't forget to write the square root. A lot of times people don't write it until the very last step, but it's easy to forget it and you need to be consistent. So let's use good notation. Okay, we've written out my identity. Now all I have to do is replace this with my fraction, which I didn't even have to do this triangle in the whole first place because the fraction is given to me. All right, 1 minus the fraction is negative 5/13. And now we are just going to simplify. So we need to find a common denominator. And then I'm going to keep, change, flip because I don't do well with double fractions. You may be able to do it in your head. I cannot. Okay, this is over 13. So I need to put this over 13, which means I need a 13 on top. 13 over 13 is the same thing as 1. So now I can write this as 1 fraction. And it is 13 minus negative 5 makes that a plus 5 over 13. So notice that my top part is now this, which is 18/13 over 2. Okay, so now I'm going to write it as the top divided by bottom, and I can put this over 1 if that will help. And keep, change, flip. Keep the first fraction as is, change division to multiplying, and flip the bottom fraction, the second fraction. You can either multiply this all together, or I'm going to go on and notice that 18 over 2, my 2 will cancel, and I can make that just a 9. So this final answer is the square root of 9 over 13. And I just realized that is not the final answer that we have. But we've done most of our simplifying. Now what you need to do is distribute your square root to both the top and the bottom, because when you do that, we know what the square root of 9 is. And on your Alex homework, they are going to let you stop here and leave a square root in the bottom, but I really want you to not. So we need to rationalize everything. So my final answer here is 3 square root 13 over 13. And we're done. Whew. A lot of algebra there. Just have to take it in baby steps. So I replaced my cosine with the fraction. Then I ended up with this weird expression on top, so I had to find a common denominator on top. Well, now I have a double fraction. So I did the top divided by bottom and keep, change, flip. I can cancel my 2's, one from the top and one from the bottom. Distribute your square root, one to the top and one to the bottom. Simplify, and then rationalize your denominator. So you know how to do all of this in every little baby step. This is just the first time we're putting it all together, and it does get intimidating, but just take it a step at a time and you can do it. Let's keep going though. We still have to find our tangent value, but it is going to be a similar process. I guess I should leave that there. So you can choose which one of the half angle identities for tangent that you want to use, which version. I'm going to use this bottom one. So now it's actually helpful that I used my triangle because I need to know what the so fraction is. So replace your cosine and sine with their and so fractions. So cosine is negative 5/13 and sine is so 12/13. We are going to do pretty much the same thing we did before. First, I'm going to get a common denominator. Then I'm going to keep, change, flip. All right, so common denominator. That means that I need a 13 down here, which means I need a 13 up here. So this would end up being 13 minus negative. And then on the bottom, I haven't messed with the bottom at all. All right, I'm going to go in and add across the top. So that is 18/13 divided by 12/13. You may be able to cancel this already in your head, but for me, I'm going to keep, change, flip. So keep the top as is, change that fraction bar or division bar to multiplying, and flip the bottom fraction. Side note, I just skipped actually writing this step out and went straight to keep, change, flip. I went from here to here. But if you need to write out this step, top divided by bottom, do that before you keep, change, flip. All right, my 13s cancel out because there's one on top and one on bottom. And you could already cancel out some of these numbers here, 18 over 12. I can take out a 2, and I can take out a 3. You may have already figured that out in your head a lot better than I did. Okay, 3/2. So I could have taken a 6 out of both of those. And that's my simplified fraction. Or use your calculator. Okay, let's do another example. It'll be the same or similar idea. This time I gave you cotangent, and we're in quadrant 2 again. So go to quadrant 2, draw your triangle against the x-axis, label your sides, and I am also going to label them with signs. So from the origin, this is the negative direction, the positive direction. Hypotenuse is always positive. All right, cotangent is the reciprocal of tangent. So instead of the TOA fraction, I have the fraction. I know that's not really what it is, but whatever. I flipped my TOA fraction to get cotangent. So that tells me that my adjacent side is 8 and negative 8. I should make sure that that negative is with my 8. If I don't write them beside each other, I'll forget it. And my opposite side is 15, and it's positive. The negative doesn't necessarily have to go with the 8 if you're just looking at this number here. I know the negative is with the 8 though because orientation on the coordinate plane, this is the negative x direction and 8 happens to be here. All right, find the third side using Pythagorean theorem. I don't use signs when I sub this in. Okay, let's figure out what the cosine half angle identity is. Reminder, this is the formula we're going to use. I'm going to replace cosine with its fraction. So that would be just the cosine, so that is -8/17 cosine theta. All right, and just like before, I need to get a common denominator on top, and then I'm going to keep, change, flip. So I need a 17 down here, which means I need a 17 on top. So this would end up being 17 minus 8/17 all over 2, which is 9/17/2. You don't necessarily have to write out every single step like I am, but it helps me not make mistakes if I do it this way. All right, now I'm going to keep, change, flip, and I can write 2 as 2/1, so it makes it clearer what I'm flipping. So keep, make sure you still write your square root, keep the 9/17 as is, change that division fraction bar into multiplying, and flip this. I can't cancel anything out, so instead I'll just multiply straight across the top, 9 times 1 and 17 times 2. Distribute your square root to the top and to the bottom. Hey, we know what the square root of 9 is, so actually take the square root of 9. Your homework allows you to stop here. I do not. I want you to rationalize, so bring that square root 34 to the top. This is our final answer. Now we need to figure out what the exact value is for tangent theta over 2. Reminder, you can use any of those 3 identities. My favorite identity is the bottom one, which is nice because now I don't have square roots to worry about. So I don't have to do that last step that a lot of people forget of distributing and simplifying and rationalizing. Okay, replace cosine with its fraction and replace sine with its fraction. Then I'm going to get a common denominator, so I need a 17 on the bottom, which means I need a 17 on the top. 17 minus negative, add, you may be able to cancel this out without doing keep, change, flip, but I mess things up. Little mistakes will snowball into big ones. So I'm going to keep, change, flip. So keep the top as is, as 25/17. Change your fraction division sign into multiplying, and flip. I can cancel out my 17s because one is on top and one is on bottom. And then I could have also taken out a 5 earlier. I like to just do one thing at a time because, again, I mess up really easily. So now if I take out a 5 here, I'm left with a 5. If I take out a 5 here, I'm left with a 3.